I now turn it over to my colleague, Sharul. Do you want to introduce Sharul? Join us. He'll give us the motivation for what, how they are tackling and thinking about this. Okay.
Thank you, Mohan. Together with me is Ajil. I am the IC President of Malaysia, and I was last year in Lonavora with Jagdish. Vivek was not there, but we were together, and I'm IC President of Malaysia, and I'm also the Head of Technical Excellence and also Group Technical Authority in Instrument and Control. Okay, next. Okay. So changing the impossibility to possibility. There's a motion today, right? I started involved in this. My management actually challenged me. Sharul, what is the DCS of the future? What is the controller of the futures? So in Petronas, we are actually excited about things of the futures, pipeline of the future, substation of the future, future of the future. So me, instrument and control, what is the instrument control of the future? So DCS of the future, when I attended ARC forum back in 2016, I saw this ARC forum presented by ExxonMobil during that in Orlando. I saw, this is the future, this is the future. So I follow closely that event. So every year they will update. So I wish, to my heart, I would like to be on the group. So I went to volunteer myself during the COVID time, 2021, to offer myself as the co-chair of the certification work group. And they welcomed me. So I went on board, become certification work group co-chair together with Intel. My partner is from Intel, which is Edward Aegis. He is the software generation director. So we went and get deeply involved with. So I'm the co-chair certification work group. And we participate last year in ARC Japan and also India through the online. So first time I'm seeing Ganatparam in person. Ganati Raman, sorry, in person. And thank you for the invitation. Okay. So we announced in ARC 22 in Orlando that Petronas is going to execute the test bed. But this time it is different from what being done by ExxonMobil and other partners. So we went ahead and deployed at the actual training plant. Okay, training plant. It is actually not a lab environment, but at the field, actual valve, actual transmitters hook up to the actual process. So right now we're actually in commissioning stage. It's already deployed, it's already installed at the site, and now we're actually testing the system. And we signed a collaboration agreement with ExxonMobil back in 2022, and sharing our learnings. We are working with Intel, for example, to get the additional DCN for us to check the interoperability. All right, okay. So I'm not gonna explain what is OPA, as has been mentioned by Mohan. So it's generally basically moved from a legacy system to an open, interoperable system. So we actually engaging Yokogawa as the system integrators to assemble 4 DCNs, 4 controllers, which is the Yokogawa itself, the Stahl, Phoenix Contact, and AS Rock. So we put these controllers on the same racks and let them actually operate as a single unit. So in the past, we only see one vendor, right? Controllers. But now we are having that mix of vendors. Just like the transmitters, we can put any brands of transmitter X, Y, Z at level 0. And now we are going to do the same, democratize that level 2 from only being proprietary to mix of controllers, right? So that's the idea. So we are going to plan to install at our INSTAT is our Institute Technology of Petronas, a training plant, about 200 I/O points, and connected to the upstream process. Okay, if you can click that video. Hopefully it can play, but if it's not going to play, then because of the connection, I will. Okay, I'll try to play it later on. Okay. Okay, this is the video. Can you try one more time? I will play the video on the last part, okay? I'll move on to this one. So the stage now is we start appointing Ikogawa as integrators. And now we are at this stage now, we are here. Commissionings, we're actually here now. And next week, we will hand over to our Institute of Technology Petronas to basically let them operate it. And then we will, for any of you who are interested to visit that systems, let me know. So I'm open to anybody who want to visit this testbed. Okay, so for us to actually move towards actual deployment adoption, there are things that we need to do. We need to change from the non-believer to the believers, because there are a lot of non-believers outside there who said, this is not going to work. People are not going to buy this mix of controllers because you lose out that warranty, you lose out that single accountability. There are many, many excuses. But as we moving towards innovation, we have to change that impossibility to possibility. If you look at from negative things, it will become negative. If you look at from the positive, it will become positive. That is actually innovation. So there are a lot of things that you have to learn. You have to prepare the workforce. Part of the digital transformation is to prepare the workforce. A lot of new things that is happening. They have to understand, especially on this one, the IT technologies. There are a lot of IT technology insertion into the OT. So we need to get the OT folks, our instrument and control, to get used to the terminologies. So there are a lot of things, for example, this PLC open, the distributed function blocks, this redfish system management, OPC-UA. These are a lot of new technologies insertion into the OT, and we have to prepare our workforce. Example, when you are talking from device to device, conventionally we are using the Modbus TCP. But moving forward, we are actually subscribing to OPC-UA, which is security by design and timestamp, as opposed to Modbus, which is not timestamp, which is not security by design. So that kind of transformation, part of digital transformation, we need to get the buy-in from the engineers. Okay, our system, as I mentioned, comprises the controllers ASRock, Phoenix Contact, Yokogawa, Star, and we actually bring in Intel to basically check for interoperability. Intel. And if you can see here, there are this engine, the runtime engine, HMI alarm reports, historian alarm view, those the things that you can see in the conventional DCS. The new things is the system management. The system management is the IT technology that's actually managing the resources, managing the memory, managing the I/O, managing the firmware version that you can actually retrieve the information online to the center, to the centralized to the centralized system, to the server. In the past, the proprietary system or legacy system, if you want to do the obsolescence management requirement, you have to go to the rack, jotting down the version, the firmware manually. Now, no more. The system management will pick up automatically that information from the racks, and you don't have to go to site. This is how powerful the IT technology, which has been used in the IT world, now is being used at the OT world. Huh? So obsolescence management will be no more painful. Okay, this is the process that we actually attach our open process automation to, the live process. It is actually one of the low pressure separator in the upstream plant. And okay, this is the detail of that architecture. Look at this. If you want to do, you want to embrace this tomorrow, total rejection from the engineers, from the technician, from the management, because what we are doing is we are decoupling a lot of modules which is in the past, in the legacy system, are embedded, not being seen, not being made visible to the eyes of the engineers, to the DCS technicians, to the operators. Suddenly we are decoupling it, we are decoupling it. We are having broker, for example, we have OPA server, we have Redfish, we have these functional blocks. This thing was not seen in the proprietary system. It was hidden, it was embedded. But now we are decoupling it because we want to make it interoperable. Interoperable means you are standardizing the interface. So you have to decouple that. So this is a pushback from the operators, from the engineers, technicians. If we don't educate them, we don't build the capability that, hey, this is something that is not that difficult. Once you master it, you are there. And it will even make you a valued person because you're actually improving your capability in terms of IT technologies. So you're actually adding values to the engineers and the technicians. Example, the brokers. Suddenly we are introducing the brokers. When the broker fails, the broker is basically to function as the agent to get the certification engine from the group discovery server. So we are introducing this group discovery server, and it is not there before. So this has to be educated to them. Why we are actually global discovery server? Because of the requirement of security. When it comes to cybersecurity, there are certificate of authority introduced inside the architecture, which is never before. So in this OPAS architecture, it is actually a built-in features. We have Docker, Linux, Redfish. These are all IT technology that we have to actually introduce early stage so that we don't scare them off. That is a part of Petronas' mission to actually have the test bed, let them play with it, let them understand it, challenge it, and so that they get used to it, and then let them fail at the training plan. It's a training plan. Let it fail, no problem, but they learn from that. And this is what I say. There's a lot of terminologies from the IT world that need to be familiarized into the OT world. And this factory was done back in November 2022. We have mix of controllers, and we move on to site. I think I can say to Mohan, right, we are the first in the world for OPA system tied to the actual field system. And 100 points, 200 points. But Alvan will be doing 2,000 points in Q4. So that will be a bigger scale. So we're waiting for the success story of that ExxonMobil field trial to actual chemical plant. But Petronas is not actual plant, it is a training plant, but good enough for us to get the confidence level. So this is a system which is already part of the commissioning. We can see it is part of the, when we actually pressurizing the separator, we can see the pressure start to build up. So this is the system that we bring to site. We actually part of the deployment to site. And this is actually a relay function actually to switch from, because right now the system is run by Honeywell, and we want to use OPA system, we have to switch. So this is actually a switch button to switch from Honeywell system to the OPA system. So this is the kind of integration to site. And here, for example, it's nice step change. It's part of the process. It is part of the commissioning at site now. Okay, key takeaway and way forward. Okay, we are going to continue with OPA capability building not only within Petronas, but also with the system integrated vendors. Okay. This is a very, very important element because when you want to deploy new technology, that technology is basically should be supported by the local vendors. Currently, the expertise lies at the United States. So that expertise has not yet been cascaded down to the local vendors. So when we do a test bed, what we are doing is basically we are forcing the local vendors to learn on the high, steep, accelerated learning curve to understand the OPA because they have to build it. So what they're doing is the local vendors has to communicate with the US nighttime, and then daytime they do that activity. They have problem, they communicate with them nighttime because the time zone between Malaysia and US is basically 12 hours, midnight. Nighttime is actually the daytime for us. So we are forcing the local vendors to learn at a high, accelerated, steep slope what is the system, because they have to build it, they have to deliver to Petronas. We have a spec that they have to deliver. So that is actually very important for the vendor to be capable as well. Unlike there are other options, which is OPA system on the box. There are agents or vendors actually selling that OPA system, built-in system, and we lease it, we buy it, or we lease it. But that is not good enough. This one, we build it from scratch, so we can understand the pain, what are the issues when we actually constructing it. It's different from deliver in the box. So I'm glad that we actually chosen these options. And next stage is looking at the possibility to replace, as I mentioned, Modbus TCP to OPA or PCUA for both legacy and new capital project. Why I'm saying this? Because the OPA system, the backbone is OPCUA. So the OPCUA right now is quite matured. There are thousands of members actually part of the OPCUA. So we want to push OPCUA as the replacing the Modbus TCP because with replacement of this at the legacy system and new system, it is the next bridge to the OPA's subscription. And we're actually, of course, waiting for feedback from the ExxonMobil success story, field installation, 2,000 points, the Baton Rouge, Louisiana. And from there, we will carry out project risk assessment on the adoption of the OPA system. We have to do risk assessment because everything, when you want to bring technology, risk assessment has to be done. I would like to give you one example that one technology that is not successful deployment is basically the foundation field bus. Foundation field bus has been greatly pointed as the technology that can replace cables, thousands of cables. We replace cable with one fiber optic. But one weak point about foundation field bus is that there are segments, and that segment has many valves, has many transmitters. But the segment tends to fail for whatever reason. And when the segment fails, a lot of valves fail, that's actually simply tripping the plant. You cannot have one or two control valve fail, 3 valve control valve fail, that actually tripping the plant. That's a bad thing about foundation field bus, which is not being highlighted that before. So we immediately aborted our embracement of foundation field bus. We installed it at the floating plant, FLNG plant, and our refinery, and then we stopped. We don't want to deploy anymore because of the bad experience. So this example, I use it to actually deploy the OPA. So we have to be very careful in deploying new technology, no matter good, it has to be done stage by stage. So this is the stage by stage that I'm talking about. If Petronas did not do this, for whatever reason, by 2025, the system very successful, then Petronas will be 2 to 3 years left behind. Why? Because if by 2025 the system is sold out, very good, a lot of embracement, a lot of success, Petronas will say, carry risk assessment. My management will say, Sharul, carry risk assessment because it's a new technology. I don't want to hear a story like foundation field bus. So while we are doing risk assessment, also the engineer technician will say, I'm not familiar with the system. I need training. That will take another 2 to 3 years. So we will be left behind another 3 years. Maybe by 2028, 2029, only then Petronas management will say, okay, you can actually use OPCUA, or you can use OPAS. By the time other competitors is already way beyond us. So with that, I thank you very much. I'd like to play the video if possible. Let me, but no. Oh, not possible. Okay. All right, with that, thank you very much. And